Uh, yes, so I'm Ben. I am a new student at Rutgers. I've never been to one of these before, which I count as a blessing and a curse. Partly because, well, a blessing because I have no expectations and I feel like the bar is set pretty low for me. But also a curse because maybe I'll just do it all wrong. But, we'll just go with the flow. Hopefully you guys are tolerant. So the the title of this presentation that I gave when asked for it was something like bringing open source software to the factory floor using ROS-Industrial. And I'm actually wearing my ROS-Industrial T-shirt just for you guys. So I thought the fashion choices are appreciated. Let's see. So I made a couple slide things, but I really want this to be less of a me talking at you guys and more of like I say something and it causes a thought and someone unmutes himself and
Hey, Ben, let me interrupt you just for a second. Yeah, Ben, hold on 1 second, brother. Would you mind
be a
just
lot more
turning
fun
off
if there's
your
more
video?
conversation than just a lecture.
There you go. Perfect.
All right. Yeah, good call. I showed my shirt. That's all I need to do. Okay, this is the title I just said. This is me, this is club, and this is today. So this is what I want to do in the time that we have, which I am guessing is like an hour, but I'll hang out for however long people want to hang. Or if this wraps up in 5 minutes, that is how it goes sometimes. So yeah, I want to start off by just getting to a sense of who is on the Zoom call, because although I know very few people at Rutgers in general, I especially don't know some people on this call. So after we do a little bit of that, I'm going to tell you a bit about myself and my experience with robotics, as sort of who am I and how I came from being a true novice in robotics to being a quote unquote expert, which is like a weird way to describe yourself, but I'll just use it for now. And then go from there to actually talking about like the sort of technical stuff, but I want that to be more of a segue to, a broader conversation about applications of robotics or applications of open source software in actual industrial spaces. So to get a sense of who y'all are, I was hoping that you could all just leave a chat thing. Just it'll have your name, but I'm curious to know what year you guys are in, what your major or department is, and just give me a favorite robot of yours, whether it's a fictional one or a real one, just something to make me feel like I'm actually interacting with people. So I'm gonna stop sharing for a sec so there's no weird embedded window thing. And I'm gonna look at the chat. Cool, Jack. Like in Marvin, nice. Who else we got? I see 12 participants in here, and I'm not gonna move on until I get at least like 3 comments in the chat. Cool. Thanks, Faith. Awesome, Hichol. Gundam, cool. All right, I'm gonna keep going, but I'm expecting all 12 participants to do so. Oh, I should do one myself. Yeah, so I do actually like R2D2 a lot. Cool. Much appreciated, everyone, for participating in that. I feel like it's at least one kind of cool way to leverage these kind of crappy virtual platforms. All right, back to sharing. All right, so that's who are y'all, and now who am I? I've actually been rocking the Les Mis soundtrack a lot recently, so who am I is clearly 24601, which is the prison number of Jean Valjean. But anyway, who am I? I'm an enthusiast of musical theater as well as a native of New Jersey. I got my bachelor's and master's from Cooper Union, which is this place, in 2017 and 18. And after doing that, I moved down to Texas, to San Antonio, where I worked at Southwest Research Institute for the last 4 years. So I did that until, I guess, this summer. And then I left that job to come here to do a PhD at Rutgers. So very excited to be here and participate in this community. So let's see. We've done all our introductions now. So I'll share a little bit more of my experience with robotics. And I saw that we have some people from varying stages in their academic careers, and I don't know how experienced everyone is in robotics, but I figure it might be interesting to just see what my experience has been with the industry, or my trajectory has been, and take it for what it's worth. And I'll reiterate, if you have anything to add on, please just unmute yourself and hang out with me. So to talk about my experience with robotics, I figured that a good place to start was with this presentation that I gave when I was actually applying for that job at Southwest Research Institute. So if you've got any interviews coming up or have to give a presentation for an interview, feel free to use this as reference because it was successful. So for this presentation, for this interview, my goal was basically to highlight the experience that I'd had up to that point. So this is sort of everything that I'd done with robotics up through 2018. And they focused on these 3 sort of mobile robotic system projects that I'd worked on. One was for a class at school, this autonomous sumo robot. The other was for an internship that I did at NASA at Marshall Space Flight Center in Alabama. And then this third project that I did was kind of using some of what I learned at NASA for an independent study during my master's at Cooper. So I'm not going to go through everything here because there's like a lot of not super important stuff, but I'll just use this as a springboard to talk about my introduction to robotics, which was in this class that Pigbot here was made for. Maybe I got a better picture of Pigbot somewhere. Yeah, here he is in action. So this was kind of the introductory mechatronics course that was offered at Cooper. And it was a really great way to learn how electromechanical systems work and interact with each other, as well as get a chance to write a little bit of software, because I come from a mechanical engineering background where there's not really any requirement to learn much about programming. So this was a great way to kind of get my feet wet with that and understand a little bit more about how powerful software can be to control mechanical systems, which is, I think, sort of where my interest largely exists. I don't love working in simulation or in theory. I like to actually make things move. So that's the mechanical part of me. But a lot of the robotic stuff that I've worked on has been kind of software centric. So anyway, I took this class at Cooper, which introduced me to robotics, and I liked it a lot. And then through some whatever great stroke of luck, I landed an internship at NASA the summer between when I got my bachelor's and when I did my master's. So that was the summer of 2017. And the project that I was working on was this, it's called the Habitat Maintenance System Simulator. So a habitat maintenance system is what's pictured in this cartoon here, kind of a robotic single-person spacecraft that does maintenance on the exterior of a deep space habitat. So imagine you're on your whatever 18-month journey to Mars, and something hits your spacecraft, and you need to go patch a hole or fix something, and you have to go out there. Usually, or the current way to do it is just use a spacesuit, but there's a lot of downsides to spacesuits that I can go into if you guys are interested in. But long story short, NASA wanted to build a robotic system to do this. And before building this and launching it to space, they wanted to build a simulator for it to understand how a person interacts with that system, kind of understanding the human factors and what kind of feedback a person needs to control that system effectively. So that's the actual system that I worked on, was this kind of mock-up of that single-person spacecraft, which would, it was actually kind of a hovercraft. I think I got a picture somewhere. Maybe.
Ben?
Yeah.
Can you say more? I think I didn't understand. Is this like a attachment to a human? Like, is there a human with this little space thing, or is it totally autonomous and it replaces the astronaut?
Yeah, great question. So the answer is both. So the intention is for a person to be able to go inside of it and operate it manually, but also since it is a robotic system, it can be teleoperated as well. So for some sort of maybe routine maintenance, it can be done remotely or from somebody inside the habitat. But if there's more complicated or unclear issue that needs to be resolved, then a person can go inside and perform their duties like they would if they were in a spacesuit, just using their human judgment. So yeah, you can see in the mock-up that we had, there's actually this little chair in there that people would sit on. I don't know if this video works. Oh. I'm gonna play it faster because it doesn't move very fast. Oh, well, okay, it doesn't matter. Anyway, the thing moves around and it's cool, and there's a bunch of sensors and actuators on it. And coming from just that sort of basic mechatronics course where I'd made that little sumo robot, this was kind of a quantum leap in complexity and capability. So there was a huge learning curve to get up to speed with what was going on with the system. And the biggest part of that was understanding the brains of it, which were done through the software tool called Robot Operating System, or often referred to as ROS. So this system was built in ROS, and I had never heard of ROS before that summer. So it was a bit of a rude awakening to have to, figure out this whole new software thing. And I'm a mechanical engineer anyway. What am I doing writing code? But it was a really valuable experience to learn about that software tool, and I actually got really excited about it at the end of the summer. So that's pretty much the motivation for the third project that I worked on that's in this slideshow, which was that independent study I did in college, which was operating a haptic controller to move around a mobile robot. So this is basically a joystick like you have to play a video game with, but it's able to push back on your hand if you run into a wall or something like that. So truth be told, I didn't actually do anything exciting or novel over the course of this independent study. I basically was just trying to learn more about ROS and keep those skills fresh, which was very useful when I got to this job at Southwest Research Institute, where they do a ton of stuff with ROS. So I'm guessing that some of you have probably heard of ROS, others maybe not. But I guess I'll take this opportunity to go through a little bit about what ROS is and how that is used, or how we use that at Southwest Research Institute to build really cool systems for actual, big companies that are building airplanes and cars and doing all sorts of things. And yeah, let me bring that up. See if I got it here. You guys have any other questions so far about my experience with robotics or how I came to be doing any of these particular projects? If they do come up, just feel free to shout out. So
Can
one
we
of
go
the
back
things,
to the astronaut thing again one more time? So like,
yeah,
I don't know how factual this is, but at least in Tom Wolfe's Do the Right Thing, the initial, which is a novel, so I don't know if this is real, but he says that in the beginning, like all the spacecraft were intended not to have, astronauts or basically drivers, and that it was like the hubris of the US Army that required that humans be involved at all. And it made the building of the spacecraft like so much more difficult because it had to have like systems for human life support. So was that a discussion at all when you guys were building this? Because you said, it's an option, like there can be a human there or there can't, but it seems like even having a human option is so difficult to add in that it must have been seen to be really valuable. And so I'm just wondering if you were part of any of those discussions.
so the short answer is no. I kind of showed up and we're like, hey, here's the project for the interns to work on. But that said, I think that's kind of one of the, and I had a great time during that internship, so I don't have much shade to throw, but it's a kind of sort of assumption or oversight, or, we're doing this just because the way it's done attitude that is pretty easy to get in trouble with. So I think it would be a really cool conversation to get into, probably not right now, but like the actual requirements of the system and whether it does require a person or not. Just like off the top of my head, I've read accounts of the assembly of the Hubble Space Telescope and how astronauts actually had to be out there like turning wrenches and aligning stuff. So I think that there probably is a place for people in space exploration stuff, although the amount and the sort of degree to which they're embedded in all these systems is maybe something that should be revisited before expending billions of dollars on it.
Great answer, Ben. I will stop holding you back on this astronaut question now. You can-
No, honestly, like I would love to just talk about space stuff.
Yeah, no, let's chat about space at some point, but you should finish your presentation.
Okay, cool. And I'm going to push back on the word presentation because I really do want this to be more of a conversation. But anyway, I'll continue with my slideshow. So at Southwest Research Institute, we did a lot of cool things. So just a little bit about that company. It's a nonprofit independent research organization. So basically any money that, so we make money by doing contract work for other companies, sort of serving as an advanced R&D wing for companies that don't have that. And then any money that we make, since we don't keep it as profit, we reinvest into internal research efforts or capital. So, new toys and robots to play with. So cool place to work at. I'd be happy to tell you all more about that, whatever. But one of the things that came out of some of this internal research that had been invested in was this ROS-Industrial project, which, to be clear, is not distinct from the ROS project. It's just kind of a subset of it. it's actually, well, I'll get to it later. But the point I'm trying to make is that at Southwest Research, we usually call it SWIRI, but at SWIRI, we spent a lot of time developing this tool set, using it, and also trying to educate others about it so that they can use it. So what these slides are from is an actual training course that I taught several times and participated in, and these slides are a little bit old, but they definitely get the gist across. And I'm not going to go through the whole thing, but I figured it would be valuable to understand a little bit of what ROS and ROS-Industrial are before talking about how it can be used in real industrial applications. So this is all open source, by the way, as well, all this training material. So I figure maybe sometime in the future I can actually try to teach that class if people are interested in it. But yeah, introduction to ROS. My favorite, I think that we changed the slide actually, but we're gonna skip over the ROS 1, ROS 2 stuff. Not super important. But yeah, my favorite, I think this used to be called like, who is ROS? Because it's like a name, but it's also an acronym. It can be kind of confusing if you're not used to it. And I'm fully aware that I've been embedded in this world for the last 4 or 5 years. So if I skip over something that's unclear, please let me know or just ask about it. I'm not really looking at the chat, so just shout out. But anyway, ROS is a software tool that's really valuable for robotics because it allows you to interface a lot of different, like disparate devices that come from different worlds. So you can have a robot from one manufacturer working with a robot from another manufacturer, working with 3 different kinds of cameras and a LiDAR and a pressure sensor. So these are all things that if you were just going to use their sort of built-in APIs or programming interfaces, it would be really complicated to write a custom application, and you wouldn't have a lot of portability between them once you wrote it. So ROS is a great layer to connect things together, and that's what you're seeing here, is that it provides this software interface for these different sensors and actuators which influence and understand the environment that a robot's existing in. Oh yeah, this is the one that was who is ROS. So what I was just describing about connecting different sensors and actuators with standard libraries and software tools, that's really the plumbing piece of ROS. But there's a lot more to it in addition to that plumbing, which is really useful from a practical, we need to make stuff move perspective. There are also tools that are built in. Well, they're not built in, they're developed by people. ROS, I don't think I mentioned, is an entirely open source project. Started at Stanford and then spun off into a company, and that company got a new name. But it's all open source, all freely available to install and use and play with and break and contribute to. And I encourage all of robotics people to learn about it. It's definitely not the be-all, end-all of robotic software, but it's definitely a great set of tools worth considering for a project. And I guess I'll make a side note here, which is at SWIRI, our job was to build robotic systems for our customers. And this ROS thing was kind of a side project where we were really interested and it was really useful and it made our jobs easier. But something that we always had to be on guard for was becoming overly comfortable with our solutions. And what I mean is that sometimes ROS is an amazing way to solve a problem, but sometimes it is not. And if you're really in the tunnel of this is the way we do things, these are the tools we have, let's go make it, that can be very limiting. So although I'm right now shouting from the rooftops about how great ROS is, I also want to caveat that with it is just a tool, and it's worth considering the actual requirements of a system before diving into one architecture, which I guess is more on the engineering side and defining requirements, which is a fun and cool part of engineering as well.
Ben, I'm going to interject with a quick question, if that's okay.
Yeah.
So I'm in this NLP space, right, like natural language processing. So I don't deal a whole lot with the programming of robots. But I did take a robotics class a year ago. And since then, and in that class, a lot of people talked about ROS. In fact, I think there was like optional extra credit to even do things in ROS. But I didn't hear a lot about like competitors. Like if ROS is usually when you have like an open source sort of thing that does something really well, usually there's something else out there that does things a little bit better but costs a lot of money. So I'm just curious, is there like a competitor out there that you guys are like, yeah, well, we could do this in ROS, or we could do this in some other thing that's a competitor to ROS?
That's a really good question too. And I think that the short answer is that no, there's not really a competitor to ROS. And a big part of that is because it's all open source. So even within the ROS universe, there are kind of competing interests and people that prefer using ROS with Python, and people that say, if you do that, you're crazy. You got to be using C++. And then there's this piece here, capabilities, which is, on top of the hardware interfaces, which is like dealing with sensors and robots, there are capabilities for doing cool things with them. So there are interfaces to OpenCV to process images, or point cloud library to segment 3D data, as well as motion planners for robots. And all of those capabilities, which are in individual packages, there's certainly competition in the ROS universe amongst different ones. At SWIRU, we spent a long time developing this motion planning framework called Tesseract, which is kind of a competitor for another ROS motion planner, which is very widely used, called Move It. And they're both good for different things, but I guess my point is that there's a lot of competition within ROS, but as far as not using ROS, I think that really the alternative is just doing it from scratch. Yeah. So, robots have their own programming interfaces, and cameras have their own APIs, and you can include those libraries and do stuff with it manually, but the availability of these common drivers makes it a lot easier to, link things together. Right. Although there is a company I learned about last year called, I forget the name of the company, but their product is called Forge OS. And what that is just for industrial robot arms, but their value proposition is that you can control any robot arm with the same kind of controller. In the world of industrial robots, it's like speaking different languages to talk to each of these different robots. So that's a big barrier, right. And one of the reasons why ROS is nice. But this company that has this Forge OS product was doing a similar thing. And we did talk about that as a little bit of a competitor, but it's very limited in the scope of it, which is a good and a bad thing. I mean, if you're only interested in doing industrial robotics, then maybe that is the way to go. And they actually have like a product that you can buy and customer service that can help you when it doesn't work. Whereas ROS is just an open source project that is contributed to by hundreds of thousands of people. So there's not really tech support for or my drinking a lot of this ROS Kool-Aid over the last 4 or 5 years. So I'd love to learn about some other tools that are out there as well. Yeah, thanks for that question. So I talked a little bit about capabilities and how that builds on top of the sort of lower level interfaces to allow you to do actually cool things with the robots. And then I don't think I talked about the tools as much, but that's something that's like visualizing in a 3D scene what your data looks like or what your robot looks like. So that's like not something that you actually have to write code for. It's just something that you can use, and that's built into the ROS packages. And then there's this last piece, which I think is probably the most important, which is the ecosystem, this open source community that supports ROS. And I think there's maybe a better picture somewhere else. But the short of it is there's a lot of people that work on it, and there are great resources. If you do, there's no actual tech support number to call, but if you post a good, thoughtful question on one of the sort of Stack Overflow type pages, you'll get a really thoughtful answer from someone like me or someone at Sweary or wherever that really knows about the stuff and kind of cares about helping other people learn to use it well. So although there's no customer support, it's almost better because you don't have to pay for it. Also worse because you don't always get an answer. But let me see. So we talked a little bit about the plumbing. I'm not going to get into like the actual technical stuff of it. Oh, here's a good picture of all the different. Well, this is not anywhere near all of the different hardware that has a ROS driver, but this is just a small amount of it. And the thing to realize is that because these things are all plugged into ROS, they all have ROS drivers, you can easily, relatively easily switch your camera out, switch your controller out, switch your robot out, and there's very little overhead to do that. So we like to say that ROS enables hardware agnosticism. So if you're a company and you're spending $100,000 on each robot to do your job, and then all of a sudden the new robot's available for half that price, you don't have to worry about writing all new code and totally upending your entire software architecture to be able to leverage that cheaper robot. So lots of cool toys to play with. Here's some of the visualization and introspection tools that I was talking about. Capabilities like that 3D perception, motion planning. Execution is really just kind of the driver interfaces. And there's a lot to talk about in each one of these. And if you guys are interested in any one of them, feel free to shout out, because I've played with, all stages of this kind of ROS pipeline at one point or another. So happy to share my experiences. Oh yeah, here's this great map that shows where ROS is being used around the world. And, as you can see, it's used in a lot of places. And fortunately, most of them speak English. So if a little bit broken English at times. And I am including Texas in that category. There's a lot of people, there's a lot of countries, there's a lot of code. Actually, I'll go back to this for a second. So ROS has a lot of code in it. There's some sort of core packages that are used for just the most basic sending messages between different pieces in the software. Then there's a little bit more if you want to use the desktop visualization tools. And then since it's an open source project, pretty much anyone can make a ROS package and send it out into the universe. And that has good things and bad things associated with it. On the plus side, there's a lot of really smart people that make awesome tools. And I think even in a lifetime, you'd never be able to understand or use all the cool tools that are out there. But on the other side of that coin, there's a lot of garbage that gets put out too. And I think that the definition of garbage is also very dependent on where you are or what your use case is. So something that might be suitable or adequate for one application might be considered garbage to another. So it's worth just going back to like understanding the requirements of what you're building. That can help drive what software tools you want to use. Let's see. Yeah, C++ and Python. I'm trying not to get into like the real nitty gritty of it and just sort of give a broad strokes impression of what ROS is and what it can be useful for.
Can I interject with another question, Ben?
Yes.
So for the planning component of that cycle you're talking about before, there was like the sensing, the planning, and then the
Yeah.
executing, right?
Yeah.
Wherever that was. Yeah. So, I mean, some of the obvious cases for planning are like robot path planning, right? You have like some sort of arm with a bunch of different degrees of freedom, and you can like program a path for it to move from, you know, point A to point B, right? So I'm curious, what sort of weird or novel uses you've seen in your experience of like robot planning, and what sort of algorithms you use to solve that problem.
Sorry, you cut out, or maybe I got disconnected for a second there, but it sounded like you were just
Sure.
asking, aside from the kind of conventional planning problems, what are some challenging ones and how do we solve those? Is that basically what you were asking? Or?
Just specifically in your experience, what have you seen? Like, what's the most interesting or the weirdest planning scenario you've had with a robot, and like what sort of path planning algorithms or planning in general? Maybe it wasn't path, whatever it was, right? What sort of planning algorithms did you use to solve that problem?
Yes. So I really appreciate that question because it lets me kind of like nerd out and brag a little bit. But there are two projects that jump to mind immediately. One was we had a robot that had to inspect basically the inside of the inlet to an aircraft, to like the engine for an aircraft. And that's a very confined area where there's not a lot of flexibility. So the solution space for the robot is very limited. And on top of that, the tool that we were using for the inspection had to come about 1 centimeter away from the surface of the aircraft. And it was very important not to touch the aircraft. So because of how heavily constrained that problem was, we had to basically throw everything we could possibly think of at it just to be able to reach all of the target areas. And then once we were able to do that, to make it do it in the desired process, like cycle time. Because if you give it enough time, you know, these planners can do just about anything. But if you want it to basically start running immediately, you need to do some more clever things. So we did a lot of stuff in like orchestrating processes and breaking down a big process into smaller ones and identifying easier regions and going for those first while queuing harder plans that would take longer to solve. So yeah, that's one thing, is working in very, very confined spaces. And I should also mention like that's a pretty easy problem if the part that's being inspected and the robot are always in the same place relative to each other. But it was a hard problem, and one that we had to solve because this robot would be presented in the part in a different place every time. So it couldn't just use a pre-canned motion and just execute it every time the part came. So it had to localize, plan, and execute, and all that without getting tangled up in all this mess of cables that it had dragging around as well. So, so that's one thing. And then the other interesting planning problem that comes to mind is one that I was really focused on for the last year because it was a research effort that I was leading at the company, which was making a robot that's able to anticipate collisions with people and then proactively change its motion to avoid the person. So if its plan is basically to swing its arm from all the way to the right to all the way to the left, if you get in the way, you might have a bad day. So the goal was to make the robot capable of anticipating that collision and then without stopping the process. So the arm continued to move, but it would smoothly change its trajectory to a new one that was collision free. And that was another big challenge in just getting it to be fast enough, because just finding a new trajectory is not so hard, but being able to do it fast enough to keep the process running uninterrupted is pretty tough. And then once you have the new plan, to be able to smoothly execute it from the already executing motion is another challenge. So yeah, getting chills just thinking about it.
Yeah, that's really cool. Thanks for sharing that.
Yeah, you're welcome. Let's see. I don't think there's a whole ton more in here that I wanted to talk about regarding like what ROS is. I guess these are just some examples of some of the online resources that are available that I can send a link to this presentation, so you guys can explore it in more detail at your own pace. Yeah, and then at this point, if I were teaching the class, we'd go into talking about what the project we'd be working on over the next few days is, which would be to identify the location of a box and pick it up with a robot. Casually, if it's even possible to be more casual, about like some of the projects that I worked on and the role that ROS played in that. Because one of the things that I've heard time and time again, and is true in many cases, is that ROS is a really great research platform, which is true. It also can be a terrible research platform depending on the project. But oh, can you guys hear me?
Yeah, we could hear you now.
Okay. So yeah, so there's a lot of things that it can be used for in research, but I also want to just push back on the idea that it is just a research platform and that it doesn't have any sort of life outside of university labs and research institutes. Because although the company I was at was called a research institute, the projects that we worked on, were for real, quote unquote, real companies that make a profit and, pay investors and sell products to other people that, we buy on the shelves at the supermarket or wherever. So I guess that's just one myth that I wanted to dispel, which is that depending on the application, ROS can absolutely be used for an actual deployable system. And there's definitely overhead involved in making it work for everyone or work at scale. But that's true for any software system and any robotic system. So that's one thing. And I guess I'll talk a little bit about some of the specific, well, not too specific, but some of the applications that we worked on, so all of these things leveraged ROS heavily. And these were projects that we did for, companies in the aerospace industry, like making aircrafts or sending stuff into space. We did projects for the automotive industry, working on, we do a lot of work on refinishing parts and surfaces. So sanding surfaces and painting them and like removing paint from them. We did a lot of that work. And a lot of it was in the automotive industry. And we did a lot of stuff for the food and beverage industry as well, which was kind of surprising for me to learn about that. And it was one of the reasons why I really enjoyed that job, was because I got to taste all these different places. I guess not literally, but got to see what all these different industries looked like and check out all of their factories and automation processes. But then try to approach the problems using the tools that we had at our disposal and were comfortable using. So I guess I want to kind of formally open the floor, and I see like in the chat there's a couple questions, but they're kind of old too. I'm going to beseech you all to continue to participate with me. What have I said that offended you or that made you curious or confused or interested, or what do you guys want to hear about?
And Ben, I have a question.
Yeah.
So each individual piece of hardware requires a unique plugin, right, to interface its specific language with ROS.
Generally, yes. I mean, you can have different robots from the same manufacturer that all use the same driver, but have different actual form factors. But for the most part, yeah, each thing has its own driver package.
Okay, so when something new comes out, I would assume that there are lots of people that are kind of immediately on top of that, trying to write those packages, but just like with any open source project. But I'm curious if there's been any manufacturer buy-in to this. Has there been any sort of first party support that you're aware of for ROS from the robot manufacturers?
Yeah, that's a really good question, because it's sort of a point of contention and continued controversy, which is for most of the history of ROS-Industrial, which is really the space where there's these really big heavy hitting companies like Fanuc and ABB and KUKA that kind of dominate the robot industry. And for a long time, they were very resistant to opening up their controllers to be compatible with ROS. And they did that for a sound business reason, which is that if you are no longer tethered to the Fanuc programming language, then you don't have to buy Fanuc robots anymore. Whereas if you're kind of trapped in that corner, you're just going to keep buying robots from that manufacturer. So, fair play to them. But the tide has definitely been turning in the last few years, and that's largely because companies are realizing that enabling or having a ROS enabled interface is actually a way to sell more robots, not fewer. Obviously I come from the perspective of doing a lot of work with ROS, but that was absolutely a driving force for design decisions when we were, brainstorming how we might write a proposal for a project. We'd say, all right, this robot has to be able to reach so far and carry so much weight, and it really would be great if it had a ROS driver, because if it doesn't, we're going to have to go to the drawing board and do a lot of overhead that we could avoid if there was already this ROS interface. So, and that's not something that's unique to Southwest Research either. That's something that a lot of other companies that use ROS surely reckon with as well. And I think it's finally beginning to dawn on some of these companies where they're saying, well, some of these robots have great ROS support and we don't, and that's hurting us. So that's definitely been changing in the last few years.
Cool. That's interesting. I have one more question, which is, you were at SWIRI for about 4 years, right?
Yeah.
And you started there right from your master's program. I'm curious, did you arrive feeling qualified for that job? And sort of on the other hand of that, do you feel like you got the resources and the support that you needed from the company, from your immediate team, to tackle those challenges, or were you feeling more sink or swim?
Yeah, so short answer up front, no and yes. I was not qualified, and I did have the support I needed.
Cool.
To elaborate a little further, when I was going through that slideshow, that was like my interview presentation for SWIRI. I think I might have skipped over it today, but I had like this one slide that had like a snippet of code on it. And the reason I put that in was because I was desperately trying to show people that I knew how to code, even though the truth is I did not. And frankly, hardly know how to code today. I like to say that I code like a mechanical engineer, which is I don't mean complementarily, whatever.
I do too, and I'm a computer engineer. So
well, that's comforting. But yeah, I think that despite my attempts to hide my lack of programming experience, it was pretty evident, and there was a lot of patience and support for me. I think I probably didn't contribute anything of value to the company for the first 6 months, but that's also probably true at a lot of companies.
Yeah,
So
and that's
I've
probably
only,
true for pretty much everyone. I mean, yeah, speaking as someone else who has like worked in industry, I think that's a super important thing to hear from someone, which is like you're gonna feel like a fish out of water. You're going to feel like everyone around me knows everything, and there's no possible way that I will ever contribute in any meaningful way. And then one day you do, and it sounds like you contributed a lot and worked on all these really cool projects. So that's really great to hear. I'm glad, really glad to hear that they did support you and that they did give you the resources that you need and didn't just kind of let you figure that out for yourself.
yeah, no, and I appreciate that is not just a experience that was unique to me as far as feeling like a total imposter, but I guess there's
Definitely
a name for that condition.
Yeah.
Yeah, I guess just another thought on that note, which is, although there were tons of resources and really supportive people, it wasn't all just like handed to me on a silver platter. It was definitely a kind of situation where I had to first recognize that I didn't know a lot of stuff that I needed to know,
Yeah.
and then also have uh, the ego in check enough to be able to go to Josh next door to me 5 times a day and say, "Hey, Josh, got a second?" And just being willing to ask for that help. And I mean, I think it's generally true that people are nice most everywhere, especially in like one-on-one interactions. So I'm a big fan of asking for help instead of just smashing your head against the computer for hours. I think
Yeah.
1 hour of smashing is good, but after that, it doesn't do anyone any help.
For sure. There's definitely a balance. You don't want to be going immediately as soon as you hit something you don't know just to go ask someone else. But I totally understand that.
Yeah.
Yeah. I mean, one other thing I think is in terms of like, I guess this sort of relates to ego, but you kind of just have to want it, right? Like you have to be willing to be like, this is going to be really shitty for about 6 months or more, depending on, how out of the water you feel. But if you really want it, then you will get to that point where you are feeling quote unquote qualified.
Yeah.
I'm going to stop taking up your time. Do any undergrads or any non N2E members have any questions? I definitely want to hear from some other people.
I was just saying there's no stupid questions, so come at me. If you missed the beginning and don't know who Ross is, I'm happy to review. While we wait for the undergrads to pluck up the courage to ask me a really dumb question, I see Lena asked, why grad school? Great question. Starting to ask myself the same thing.
I mean, it just seems like you had such a fun job. Like what was missing from the job?
So there was definitely many factors, and one of them was certainly geography. I'm from New Jersey, and I wanted to be, up here, especially after COVID. So that was definitely a major factor. But from an actual like professional technical perspective, I found the work that we were doing, though it was really interesting and challenging, I found myself missing. To take a step back, the problems that we were working on were all in the universe of industrial automation, trying to make things to automate these manufacturing processes so that they didn't really need as much human intervention, which is great for companies. Sometimes it's great for workers too. You can be freeing up a worker to do something more valuable. It's not all just taking jobs away. But I found that the projects that we were working on, since they were so centered on pure automation, like purely autonomous systems, I was missing human elements in it. You sometimes have to build a little human machine interface, a little screen with buttons to click, to put your emergency stops in places that people can reach them if the robot's going crazy. But that was about the extent of the human involvement in these systems. And I realized that was something that I really missed, was working with systems that directly affected and interacted with people. That's why I was working on that research effort that was about that robot that would try to proactively avoid a person. But even that was quite an effort to get off the ground. And ultimately, it was not the focus of the work. That was kind of a cool side project, I would say, even though I got to spend a lot of time on it. And I basically wanted to come to grad school to shift my focus from being a manufacturing automation person to being a sort of human-centered robotics person.
That's a super cool answer. I, would love to hear even more detail about that as like the sole sort of non-robotics person. But yeah, Ben, thank you so much for sharing all of this with us. Does anyone have any last questions before we let Ben go? I
We
guess
got one more in
Austin
the
has a
chat.
question.
We got one from Austin in the chat.
Yeah, I see. Let's see. Austin said, I believe you said that your first experience in robotics was in the class where you worked on Pigbot, but were there any other resources during that time that would you say really helped you learn more about robotics? So the most honest answer is no. That was basically, that class was the only thing that exposed me to it. And I have to give a lot of credit to the teacher, Brian Cusack, who was just a phenomenal teacher. And I guess that's how things tend to go a lot of the time, where you have a great professor and that influences what you're interested in, what you're excited about. But yeah, basically he gave really interesting, clear and exciting lectures and gave us assignments that were well thought out and achievable, but difficult, like making sumo robots. So I wish I had a more exciting answer to that, but yeah, aside from the class, it's really just like the people. So in addition to the professor, it also helped that the teammates that I had when I was building Pigbot, which was a group project, my teammates were also mechanical engineering students who also didn't know much of anything about the electrical and the software side of things. So we were really kind of in the trenches together. And I thought that was a really kind of formative experience. Sometimes it's nice to be thrown into the deep end to sink or swim, especially when there's a lifeguard there.
Awesome.
Yeah, thank you, Ben. That was a great conversation and
Yeah.
talk.
I agree. This is honestly one of the best N2E meetings I've attended. So yeah, thank you so much. And thanks for everyone who came. I'd say let's wrap it up now because we are past 8 o'clock. But we are all available. You can find our information, I suppose, in the student directory. And yeah, feel free to reach out if you have any questions or reach out to Ben if you wanted to learn or discuss any more.
Yeah, as you can tell, I love talking about this stuff, and I love talking to cool people, and you guys all seem pretty chill. So hit me up down to just casually hang out and talk about robots and technology and musical theater whenever. So thanks for the attention. Looking forward to seeing y'all around soon.
Awesome. Thanks, everyone. Have a good night.